Okay, I'm here to talk to you about vector components. And I said vector components are pieces that you can add together and make your vector. And so we talked a little bit about vector addition already. The idea is that a component is just any vector that when added to other vectors can make your original vector. So for example, if this was a vector, I could make any unlimited number of components to put together a total of components that make this. So I could go like, I'm going to use a different color pen here. This is the original vector. I could go like this and that, and those are two components that when added together come up with the same as the original vector. Or I could go like this instead. I could go over, and I could go down, and I could go up, and I could go like that. And so those are four components that when added together total the same as our original vector. So when you add together the components, you get what is essentially your original vector. You're breaking this vector into components. Now, even though it's possible to do unlimited numbers of components, we tend to try to make it easy by creating two components most of the time, an x and a y component. Sometimes these are called horizontal and vertical components. So this right there would be your x component, so I'm just going to label that x. And this right here would be your y component. So your x component is totally horizontal in this case, your y component is totally vertical. So x plus y equals your original vector. And I'm going to give this vector just a letter to represent it. I'm just going to say this vector has a magnitude of v. So sometimes you might write this instead of x. You could write it as v sub x, and you could write this as v sub y. V sub x plus v sub y, when added tip to tail, the tip of one becomes the tail of the next, and you'll see that v is the result of v sub x plus v sub y. And we do this because oftentimes by looking at the x component and the y component of vectors, they tell you different things. And so we'll get into the why of that later on. Right now let's just look at the actual vector components. So we can use our SOHCAHTOA rules, sine and cosine. So if we know that this is an angle theta, we know theta, the tangent of theta is opposite over adjacent. The sine of theta is opposite over hypotenuse, and the cosine of theta is adjacent over hypotenuse. So just to write that down, sine of the angle, in this case, would be opposite over hypotenuse, v sub y over v, and cosine of theta is then the adjacent v sub x over original vector v. If you rewrite these, then you can find that your component v is just your component v sub y is just original vector v times the sine of that angle. Similarly, your x component v sub x is just vector v times the cosine of that angle. So cosine deals with adjacent, so to find v sub x, you're using the cosine because it's adjacent to this angle. And to find the y component, you're using the sine, which is opposite. Now sometimes you might be given this angle right here instead. I'm just going to call that phi instead of theta. And so at that point you have to rework out the sine and cosine. You would find that suddenly the x component is the opposite. So it would end up being v sub x is equal to v sine of phi, this angle here. Or you could just say this is, hey, if I know this is 60, then this is 30, and I can work it out from there. But we're going to see vector components come into play in several places, particularly with projectile motion. You really should know how to calculate these, and these two equations are not on the reference table. Thank you very much.